Okay, so welcome back. So before we talk about the algorithm, we also need to introduce two other concepts in this page. The first one is called closed patterns. The second one is called max patterns. The main reason is because given a data in database systems, we can extract different patterns from it, right? The pattern size can be very large. In this page, we'll show you with an example. Let's assume we have a data set contains 100 items, and we will define some patterns based on these kinds of items, which can compose this item set, right? So how many different patterns we can define, or how many different item set we can define based on these 100 items? It will contain 100 choose 1 plus 100 choose 2 until 100 choose 100. Right? According to some similar analysis, we know this number, the summation will equals to 2 raised to 100 minus 1. Right? The size will be 1.27 times 10 raised to 30 sub-patterns. So we see the size of patterns can be so large. We have so many different patterns we can define. However, only a number of them will be useful and meaningful. Right? So therefore, we want to find some specific patterns which are useful and meaningful actually. So therefore, the solution we propose is to mine some closed patterns and max patterns instead. So what is a closed pattern? So given an item set, we define this item set to be X. We can say this item set is closed if X is frequent and there exists no super pattern Y. This X is one subset of Y with the same support as X. Because we know that given a pattern X, if we plan to put more item into this X, its support will be decreased, right? Its frequency will be decreased. Because if we have a small size item set and we can further input some item into it, this set will be larger. Normally, for some transaction contains this larger subset, this larger item set will be less frequent, right? So, therefore, if we have two item sets, the first one is X, the second one is Y. X is a subset of Y. We can say that Y is a super pattern of X. According to our prior knowledge, we know that the support of Y will be no greater than the support of X, right? It can be decreased or can be the same as X. It cannot be larger than X, right? Therefore, we can say if this X is closed, if and only if X is frequent is the first requirement. Also, none of its superset will have the same support as X. If so, then we can say this X as a closed pattern. And we're going to say this X as a max pattern if X is frequent and none of its superpatterns will be frequent. In other words, X is the largest frequent patterns we can find. If we include more items into this X set, it will be the frequency will be less than the bar or the threshold we defined before. It will be no longer frequent anymore. So according to these two definitions, given some data, so we can extract its closed as well as max patterns instead, which will be more meaningful. Also, in this page, we'll show you with an example. In this system, we have a database system. In the database system, we have two transactions. The first transaction is A1 until A100. We have 100 items in this transaction. And the second one is also a transaction contains A1 to A50. We only have 50 items in this transaction. And we define the mean support of this threshold to be 1. Then based on the data set, what kinds of patterns we can get which are closed. So we can get two different closed item set or closed patterns, right? The first one we can get is A1 to A100. According to our analysis, we know that given A1 and A100, we cannot find a superset anymore, right? Therefore, we can define this one to be closed item set. Besides this, another closed item set we can define is A1 and A50. We know that this A1 and A50 is frequent first of all, right? Because it is larger than the mean support. At the same time, none of its superset will have the same frequency as this one, right? Because this A1 and A50, its frequency is 2. If we plan to find a superset of this one, like A1 and A50, by incorporating more items into it, now for example, we can put A51 into it, its frequency will be only 1, right? Because A1 to A50 and A51, it will appear in the first transaction only, its frequency will be only 1, right? So in other words, all its superset will be, we have a frequency of the 1 actually. According to the definition we showed in the previous page, if this X is frequent and there exists no superset Y with the same frequency as this X, if so, then we can say this X is closed, right? According to the definition, we can say this A1 and A50 is also closed as well. It is frequent, and none of its subsets will have the same frequency as this one, right? Okay, so this is a closed item set we can get from this example. How about its max pattern? We can only find one single max pattern for this example, right? It will be A1 and A100. So according to the definition, what is the max pattern? This X is a max pattern if X is frequent. This is the first requirement, right? And the second requirement is there exists no superpatterns of this X, which is also frequent, right? So for this A1 and A50, it is frequent, right? However, we can also find a subset to be A1 and A100. It is also frequent. Therefore, we can reject this one to be the max pattern, right? How about this A1 and A100? It is frequent, and none of its subset will also be frequent anymore, right? So this one will be the max patterns as well. Then how about all the patterns? So in the previous page, we also show you the example already, right? We can define different patterns based on the data we can get, A1 to A100. We can have 2 raised to 100 minus 1 different patterns can be defined based on the data set, right? Okay, so this example we can use to clarify the difference between the closed patterns and with the max patterns for you. And you can try to use the example to understand how to define, how to find the closed patterns and with max patterns.